There are many ways to approach the history of science. Some of the ways we've used in this course are looking at particular characters, their ideas, and their position within the context of their times. But another way of looking at the history of science is through the history of institutions. That is, what kind of places were the home of natural philosophical inquiry. We've done some of this already because we saw that in the Middle Ages, a crucial development of the Middle Ages was the origin of the university. The university gave a home to the study of natural philosophy. Well, down into the period we're talking about now, in the 17th century, the universities, both those founded in the Middle Ages and those founded since the Middle Ages, continue to be important institutional centers for natural philosophy throughout the 17th century and, in fact, of course, down to the present day. In general, in the 16th and 17th centuries, universities tended to be conservative places. They tended not to adopt the newest ideas as quickly as people outside the universities did. So generally, they were rather conservative, but they certainly weren't hidebound by any means. They did continue to develop in various ways. The universities were, of course, widely criticized by important figures of the scientific revolution. We've heard the critiques by Bacon, Van Helmont, Descartes, and many others. The development of an intellectual class outside of the universities, due to increasing wealth and leisure in the Renaissance, led to new kinds of associations and new kinds of groups, not connected to the universities. In the Renaissance, the first of these were generally belletristic. That is, they dealt with beautiful literature, with good writing, with rhetoric, with language. They were humanistic associations and artistic associations. But later, however, various people who were interested in natural philosophical problems and issues began to associate into groups. The earliest of these scientific societies were organized in Italy in the early 17th century. One of the most important of these was the Accademia dei Lincei, which means the Academy of the Lynxes. That's a rather curious name. Well, lynx, you know, is a cat-like animal. The name also comes from the Greek mythology about the character Lynceus, whose eyesight was so sharp and so piercing it could see to the very foundations of things, or through objects, to find their true nature. And the lynx was known, the animal in this case, was known for its very keen and piercing eyesight. So they named themselves the lynxes because they were peering in to the recesses of nature, seeing things as they really were, or at least trying to. Well, the Accademia dei Lincei was organized in Rome in 1603 by Federico Cesi. Cesi believed that the uncovering of the workings of nature had to be carried out by a corporate effort, an effort of scholars working together on common projects. This is actually similar to the view of the scientific method that Bacon would propound later in England in his influential works. The Accademia began quite small. It had only 4 members, including Cesi, in its early days, and after some difficulties in the mid part of the first decade of the 17th century, it began to grow after about 1609 to include a very diverse cast of characters. And let me illustrate the diversity of this cast of characters by mentioning 2. In 1610, Giambattista della Porta, who was an advocate of natural magic, was admitted. We mentioned him back in our lecture on natural magic. He had, in fact, organized, while he was still a teenager in Naples, an Academy of the Secrets of Nature, which tried to look for the correspondences between things, new kinds of technologies, of wonderful, magical, wondrous machinery, things like this. He had done this in the mid-16th century. The results of this little academy that he founded were published in 1558 under the simple title of Natural Magic. The following year, 1611, Galileo is made a member. One of the important associations with the Lincei was that he showed them the 2 instruments which he called the occhiale and the occhialino. And it was the lynxes, the Lincei, who renamed them not in Italian but with Greek origin, with roots of Greek origin, the telescopio and the microscopio. So they are the origins of those names. Well, the Academy failed to become self-supporting, and it fell apart after Cesi's death and Galileo's condemnation. I should mention that it was reinstituted in 1874 after the Risorgimento, the unification of Italy, to become a royal academy of the Lincei, and nowadays it still exists as a national academy. Well, another Italian group was the Accademia del Cimento. Cimento, literally the cement. That's not concrete kind of cement, but rather it's a kind of test for the purity of gold, where gold is beaten into thin plates and smeared with salts, put in a fire, and all the coarser, baser metals are corroded out, and you get pure gold as a result. So this Accademia del Cimento, the sense of that name was that they were going to look at ideas in the world and try them, test them out, and only take the ones that were good. It was a much looser grouping of natural philosophers, centered in Florence around the patronage of Duke Ferdinando II of de' Medici. It was active for just a short time, just about 10 years from 1657 to 1667. Many of the followers of Galileo were active here, and there was a lot of work done on the Torricellian tube, the barometer, and the thermometer. Well, these weren't the only ones in Italy. There were quite a large number of Italian scientific societies that were started in many Italian cities. However, their common failing was that none of them managed to outlive their founders. They couldn't quite make that jump to be stable, long-term institutions. There were two 17th century institutions that ended up being much more stable and much more organized, however. The first of these is the Royal Society of London. It was founded informally in 1660 and chartered by King Charles II in 1662. It continues to this day as a premier scientific institution, a scientific society. Many of the most important English scientific thinkers of the day were involved in its founding. For example, Robert Boyle was a chief motivating force behind the Royal Society, as was Christopher Wren, the great architect of London, rebuilding it after the fire of 1666. Robert Hooke was involved early on, and many others. Well, the Royal Society drew much of its inspiration from the writings of Francis Bacon. Bacon had written a book which was published shortly after his death called The New Atlantis. It was about a far-off land in the South Sea, a utopian kind of culture, where they had a place called Solomon's House, where scientific and technological studies were undertaken. They would send out expeditions to collect information. They had observatories to watch the stars and watch other kinds of phenomena. They did experiments. They improved trades. They did all kinds of scientific and technological things. Well, this was in a sense a spur, a model to the Royal Society. Meetings of the Society involved discussions, presentation of new findings and papers, and demonstrations. Well, how did the Society actually work? Well, fellows worked independently. There wasn't any oversight board, so to speak, that put people on projects. They went out and they did what they were interested in, and then they reported their findings back at the Society. They would bring in reports. They also did demonstrations, and one of the important members is Robert Hooke, this very clever fellow, very clever as a mechanic with making things and doing experiments, also very clever mathematically with his ideas on light and color theory, making clocks, making air pumps, all kinds of things. The air pump that he made for Boyle became a very high-profile feature of the Royal Society. People visited meetings of the Society to watch the air pump. Many of the demonstrations involved things that we might not think are the thing you might travel out of your way to go see, like putting small animals into the glass globe, pumping the air out, and seeing how long it takes them to expire. Lots of experiments like that were done on all kinds of animals, mice, cats, birds, ducks even, all kinds of things. It was an important part of the Society to do demonstrations of experiments. But another, equally, possibly more important move was the foundation in 1665 of the first scientific journal, that is, the Philosophical Transactions. Philosophical Transactions, first volume, comes out in the 1660s, and in fact, it's still published today. The journal is actually split into several different sections now, but it's still published by the Royal Society, and it's an important organ for the dissemination of scientific material. Initially, the publication was overseen by the secretary of the Society, Henry Oldenburg. Now, Oldenburg had already been a center of correspondence for many, many years. And if we look at the 17th century, we find lots of these characters who were centers of correspondence. These were very important people in the 17th century. They were people that would begin, initiate, and receive correspondence on a wide variety of issues, often scientific ones, with a wide variety of people across Europe. And they did a lot to create, to maintain international networks of correspondence. And so, in a sense, the origin of these scientific journals is a kind of institutionalization of this more informal circle web of transfer of letters, exchange of letters. The Philosophical Transactions was able to speak to a wide audience. One of the interesting things, of course, about the Philosophical Transactions is that they choose to publish it in English, which does, in fact, exclude quite a lot of people on the continent that are not English readers. But they chose not to publish it in Latin. They chose to publish it in English. There were some articles in Latin, but not many. The journal was a place to publicize the activities of the Society and Fellows. It became a propaganda tool, not necessarily in a bad sense of the word propaganda, but a propaganda tool for the Society and its Fellows. It was a place to assert priority. Who discovered what, when, at what time. You could publish it in the journal and then point to the date of publication as an assertion of priority. Its pages were used to adjudicate scientific disputes many, many times over a whole host of issues, over the air pump or comets or various other things. And of course, it disseminated information. But it could also collect information. Many of the things that were published in the journal in the early years were sets of questionnaires that were sent out through the journal, and people were asked, particularly people that live in far-off exotic places, to send back information to the Society. Robert Boyle was one of the people very closely involved in this. He liked this idea of collecting material by sending questions to travelers, to merchants, to sailors, all kinds of people. Really, of course, what it is, it's a putting into practice of Bacon's idea, Francis Bacon's idea of collecting information from as many sources as possible, collecting the sort of raw material of natural philosophy before building a system. Well, the Society grew very rapidly. Within a few years, it had over 200 members. The problem about this was that many of these members were admitted not because they were particularly wonderful in terms of natural philosophical interests, but often because they were members of the nobility or they were wealthy. And the wealthy part is important because even though the Society was chartered by Charles II and got the name of a royal society, he never gave it any money. And so there were constant financial troubles. All fellows had to pay dues to the Society. As it turned out, very few actually did. So there are these constant purges that have to be undertaken to get rid of the inactive members, try and bring in active members that will not only come to the Society, to the meetings, and contribute scientific information, but contribute their dues as well to keep the Society functioning. So the early Royal Society nearly went out of business several times as it went from one crisis to another, the crisis of the death of important people, the death of Henry Oldenburg, the death of Boyle in 1691, various problems like this. It almost went the way of these earlier Italian societies. It really only stabilized in the 18th century, partially under the leadership of Isaac Newton, who became its president, and it's probably not until the middle part of the 18th century that it really gets on its feet and has progressed ever since to the present day. Something to compare the early Royal Society to is the Académie Royale des Sciences, founded in Paris a few years after the Royal Society of London, founded in 1666. In this case, the founding was very different. It was not a bunch of people coming together, founding something informally, and then getting royal recognition. In this case, the society was collected together by the minister Colbert, and it was funded from the very outset by Louis XIV. So it did not have the financial problems of the Royal Society early on, and this characteristic makes it a very different society in many ways. First of all, Colbert was able to go out and collect international stars, superstars, to start the core of the early Académie Royale. He collected talent from abroad for the benefit of France, for the benefit of technology, science, and trades in France, and of course also for the glory of the Sun King, Louis XIV. Some of the people he collected were, for example, the Dutchman Christian Huygens. He was the head of the new Academy of Sciences. Now, Huygens did a whole lot of things. We've mentioned him just in the previous lecture in regard to his wave theory of light. But he did a lot of other things. He built telescopes. He studied Saturn. He was the first one to explain this very funny appearance of Saturn through the telescope. He was the first one to realize that it was surrounded by a ring system, and that this ring system was inclined to the orbit of Saturn, so sometimes you could see the rings very clearly, other times they seemed to have disappeared. This confused Galileo, who actually described it, but he didn't quite make sense of what he was seeing, that it was a ring system. That was Huygens. Huygens also discovered the first satellite known of Saturn, that is Titan. Huygens also did some work with light, as I mentioned, the wave theory. He proposed, contrary to people like Aristotle and Descartes, that light might have a finite speed. He also worked on laws of motion, and one of the important things that he did from a technological perspective was to improve clocks. In 1656, before he goes to France, before he goes to head the Academy of Sciences there, he builds the first accurate pendulum clocks, the first clocks that are regulated by a pendulum. Now, it was Galileo who worked out a pendulum motion, noting that the weight of the bob on the pendulum makes no difference to its period, that its period is constant regardless of the weight and regardless of the length of the swing. That's Galileo. But Huygens put this into practice using the pendulum as a way of regulating clocks. Why was he doing this? Well, timekeeping is, of course, very, very important. You need it for astronomical purposes. You also need it to determine longitude at sea. Determining latitude at sea is very easy. Determining longitude is very difficult unless you know what the time is at your starting point. So you need to bring a clock with you to figure out what local time actually is. Unfortunately, as you can imagine, on a swaying ship, pendulum clocks don't do very well. So this didn't actually work out, at least not until the following century. Another real superstar was the Italian Gian Domenico Cassini. Cassini distinguished himself in astronomy well before he was invited to Paris in 1669 as the Academy's highest paid member. Cassini made numerous discoveries in planetary astronomy. He looked at Saturn as well, discovered 4 more moons to it, discovered that it had not 1 ring but 2, that there was a division in the rings, which to this day is referred to as the Cassini division. In fact, even as we speak, a probe is headed towards Saturn bearing the name Cassini. So Cassini did a lot with Saturn. He also organized a survey of France. This is part of how the Academy of Sciences also served the crown that was funding it. Louis XIV needed a better map, a better survey of his dominions in France. Unfortunately, Cassini discovered that France was actually smaller than was thought, and so this new survey actually made Louis's dominions slightly smaller than probably he had hoped. The way he did this was he had to find the latitude and longitude of places. Latitude's easy. You just measure the altitude of the sun or of stars, and you can calculate your latitude. That's simple. Longitude's another problem. You need, again, a uniform standard time. How do you get that? Well, Cassini used the discovery of the regular eclipses of Jupiter's satellites. Jupiter has 4 satellites that were known at the time. You can watch them move across, cast shadows on the surface of the planet. You watch them go behind the shadow of the planet and then reappear. Since this is an astronomical phenomenon and it's regular, you can use them as clocks. So he published a table in 1668 of the eclipse times, the time of immersion and emersion of the satellites, as it's called, from the shadow of Jupiter. And he used these to find the longitude of various places in France and make a new map. However, it was noticed before long that sometimes these appearances, the reappearances, the disappearances of the satellites of Jupiter were not coming at the right time. They were late. Didn't take long to find out that they tended to be late when Jupiter was furthest away from the Earth, on the other side of its orbit. This led a Danish astronomer by the name of Ole Rømer to suggest that the reason they were late is that light does in fact have a finite velocity, and it's taking longer for the light to cross from Jupiter to the Earth, and that's why the satellites appear to eclipse late. Well, he made a prediction. He predicted that the eclipse of the satellite Io on the 9th of November, 1676, would appear 10 minutes late. And when the date arrived, sure enough, it was 10 minutes late. And Rømer then used the concurrently accepted distances between the planets to calculate what the speed of light was. And he got it pretty close, certainly within less than an order of magnitude. Cassini was also the head of a dynasty of astronomers. There are 4 Cassinis, actually, who run the Paris Observatory, an institution related to the Royal Academy. His descendants run this observatory for over a century. Well, as I've already said, the Paris Academy and the Crown had much closer relations than was the case of the Royal Society to the English Crown. And this linkage had several effects on the Academy and on French society. First of all, the Academy was the recipient of royal funding, so they could recruit international and domestic scholars. This meant that all of these characters that were recruited were actually paid a stipend, unlike at the Royal Society where the fellows had to pay dues of membership. This had 2 effects. One, it meant that the Parisian Academy was much smaller than the Royal Society. Certainly nothing like over 200 members. It was a couple of dozen at the most. It also meant that this feeds into the increasing professionalization of scientific inquiry. Here now at the Parisian Academy of Sciences, you have people hired in order to study the natural world. And after the reorganization of 1699, there are, in a sense, chairs in each of the different disciplines. There's someone hired to do chemistry, there's someone hired to do physics, there's someone hired to do botany and anatomy. And so there's a broad coverage, there's a more balanced coverage at the Parisian Academy. The Academy also had use of the Royal Library and, of course, the Paris Observatory, which is still used to this day as a center of astronomy, was also at their disposal, and it was built for them. So the Parisian Academy had a stability, financial and otherwise, and attained an official and a public status that the Royal Society would not do until much, much later. Now, this, of course, comes at a price. The Crown is paying a stipend to the academicians. The Crown also expects something back from the academicians, not just for them to go off and do anything. They had a lot of freedom, but not absolutely perfect freedom in the following sense. That is, that the academicians were often called upon to be the official scientific voices, the official scientific consultants of the king. So, if there was a technological problem, like, for example, the flooding of Paris, where does the government go? It goes to the the Royal Academy of Sciences to work out a plan. You need a new survey, you need new maps of France. Where do you go? You go to these academicians again. You're concerned by the longitude problem because your sailors going to the New World in Asia can't find their longitude. Who works on the longitude problem? The people at the Academy. People at the Academy do all kinds of other things. They end up licensing books, so they read books that are to be published on medical and scientific topics, and they give it a license to be published. They also are the recipients of technological innovations like new machines, innovations in the trade, or in various trades, whether it's mining, refining, weaving, whatever. Inventions, new inventions are sent in to the Academy. They test them out, and then they advise the king on, should this be patented, should this be something that is good for France. That means that not only did the academicians have a certain professionalization, they also had a certain official status. That means that in France, these thinkers had a higher social station in a way from relating to what they were doing professionally than the people at the Royal Society. The people at the Royal Society, if they had a high social station, it was largely on account of their birth. They originally had this. At the Academy in France, although many of the people were of noble birth, well, not necessarily noble, but of high birth from wealthy families, they also had a status that was independent of that because of their scientific professionalization. Well, the Academy also published a serial, a journal, not published monthly or more frequently as the Philtrans was, the Philosophical Transactions, but annually. This was its history and its memoirs, so it had an annual publication. Before that time, before 1699, the first year that the history and memoirs of the Royal Academy of Sciences are published, it publishes reports in the Journal des Savants. That is the journal of the savants, the scientists, if you will, the people, the wise people. It's hard to translate that into English. Before that, before 1699, they also financed the publication of some extremely elegant, beautifully illustrated volumes on dissections of exotic animals that had been sent to the royal menagerie at Versailles. They also published new herbals of these new plants that were being collected from overseas and grown in the Jardin des Plantes. Like the Royal Society, they also maintained a wide circle of correspondence. Ole Römer was one of these, the person with the speed of light issue. They contributed to the memoirs, they sent in reports. Well, the Académie Royale des Sciences continued to function through the 18th century. It was, however, closed upon the disaster of the French Revolution. However, it was opened again a few years later after stability had been regained, and it continues to function today as part of the Institut de France. Now, scientific societies played a key role in creating another home for scientific inquiry outside the university, yet institutionalized. As we've seen, institutionalized in two quite different ways. In fact, in two ways that are, in one sense, complementary of one another. Both the Royal Society and the Parisian Academy hosted people that made significant contributions to the history of science and some very interesting interactions socially within each and in terms of the larger culture, the larger public. They helped generate a public status for science. It became something in the public domain. They became a visible icon of the new science. And in linking scientific expertise with the needs and the demands of the state. Well, we've come to the end of this lecture and to the beginning of the 18th century, and as a result, our journey through the history of science is nearly over. In the next lecture, I'm going to glance forward to some of the developments of 17th and early 18th century natural philosophy in the 18th century, and then I'm going to try to compose some concluding thoughts about summarizing the entire survey.